It's 4 p.m. This is the third day of the 24th Congress. If you guys have any cell phones, just a quick reminder to put them on vibrate or turn them off. Our next presenter is Thomas Rybak. He's going to be giving a presentation on data analysis of the sputnik data from the active RFID tags that were collected at the last Congress in 2006. So here he is with his talk.
Okay. Thank you. As you can see, I have many slides, so I will try to go as fast through them as possible, and then leave about 10 to 15 minutes for discussion and maybe some ideas, improvements, and something like that. This is outline. The last part is the biggest one. Sputnik, as most of you know, is intended to trace your movements inside BCC or inside any other closed area. It consists of many readers. Last year it was 25 to 27, I don't remember correctly. This year it is 37, I think. So each tag sends signals, and readers gather those signals, and it goes to the server. Those are web pages. They are also on page describing this presentation, and links to those pages are on my web page. How Sputnik is different from ordinary RFID systems. Those tags have their own source of power, battery, so they do not depend on reader. They send signals whether there is reader listening or not. And thanks to battery, they have control over power of sent signals. So this allows for estimating how far from particular reader particular tag is. And this, having data from many readers, allow for estimation of position. Like it was said, during previous Congress, data was gathered, and gathered data was made available both as XML and binary data. But unfortunately, and this is my topic of my presentation, those files have problems, and I hope I was able to recover most of the problems. XML file was taken from software visualizing positions of all participants. There was some big screen in art and beauty area, and there was running software that was showing where particular tag is, and as for debugging purposes, it was also logging into XML file positions and some other data. It consisted of many tags, which had ID of tag, time when this reading was made, position, or 000 if it was not, if software was unable to estimate the position. Direction, it was always 000, as it was not software. It was not able to calculate position, and few other data that was not as interesting as for analysis. Unfortunately, XML file consists, as it was first only for logging and debugging purposes. Second, it was running not on main server but only on visualizing machine. It gathered only small amount of data. It was only 300,000 entries, and on about 2/3 of them had any position. And its main problem with this was that this file did not consist of all data that a binary file consisted of. So I was not able to correlate those files without having any IDs, because the only thing that connected XML file and binary file was ID of tag and time. And without IDs, which in few moments, I was not able to correlate them. A binary file was supposed to look like this. It was supposed to consist of many structures. Those numbers are bytes where data is. It was supposed to have timestamp, IP of readers, which gather data, size of frame, protocol used, flags. Only 02 was seen in data. It was whether it was button pressed or not. Strength of signal, sequence number, tag ID, and checksum. Unfortunately, tag ID was lost due to error in server. It was slightly the place in memory that was saved did not consisted of tag ID. So all IDs of tags were lost. So data did not consisted of numbers telling that it was you or you or you that was going on. So it made analysis impossible, or almost impossible. But this binary file was interesting. It consisted of 11.1 million of entries. It is much more than XML file. As I said, it had missing IDs of tags. It also consisted of one rather irritating error. It consisted of 8 additional bytes that were repetition of some frame. Maybe it was example of another error of the same error, as I said, and it consisted of 65,000 repeated frames, just like those. It was a query that I used to calculate number of those frames and also to have those frames listed. I put all those data into database as it was rather large amount of data, and I did not wanted to program each time to run all those imports into from the files. Scripts for creating data, loading all the database, loading all those data files into database are on my page. And also this database can be seen as temporal, as it contains data that changes in time, and when we see it from XML dataset perspective, it can also be seen as a spatial database. So it should be possible to use database extension like PostGIS for further analysis, for example, in this year's dataset. I created a few tables. First, I created only one table that consisted of all data gathered from all files. Then I decided to move it to separate tables to have better natural models and to have easier queries. So those are tables that are created. The most important tables are sputnik. This is base table that contains data. CCC23 that contained binary data from previous Congress, and CCC23 XML that contained XML data from previous Congress. Base data consisted of those columns. ID of tag initially empty, as those were lost. Time of reading, sequence number, strength of signal, which station received signal, and array of additional information like whether or not button was pressed. XML data files was inherited from ordinary data file and also consisted of those columns. As you can see, those are mostly columns that map into attributes of XML file. I also created few another tables that I want to use in further analyzing, but have not yet used them. But a table describing one room, a table describing events, and I have also on my webpage a script that is able to populate this table using XML file plan published on CCC webpage. So this table contains some useful data. And to end about database, it is rather, maybe not it is as big as most scientific or trade databases, but it nonetheless it consists. Main table takes 700 megabytes plus almost the same size of indexes, so it is larger than amount of memory any of my computers have. So it put rather it was rather heavy for my computer to analyze this. And those indexes are necessary because without them, in making pictures, time with index it was a few seconds, time without index it was few minutes. So without indexes, analysis would be impossible. But because my operations were were changing large amount of those tables, I also have to, because I was using PostgreSQL, so I had to use vacuuming. So this is mostly technical. Description. It is in paper in proceedings. In 8.3, that should be in final version should be in a few weeks. Vacuuming is not so crucial for performance as it was in my case. And one more remark, because of technical limitations, how Postgres works, I had to use cursors for exporting data. So if anyone of you would also like to export data to run one of my scripts, you would also have to export data by using cursors, because the data was bigger than available memory. Okay, so now I'm going to the main area of this presentation, and to understand what I have done, it is necessary to go deeper into behavior of Sputnik system. Each tag, as you can see, each tag has diode that blinks. Each blinks means that it sends a signal into the reader. This transmission is encrypted to avoid listening for signals or tampering with this, and also to avoid reply attacks. Each tag has its own counter that is incremented each time it sends signal. So each tag sends signal once every few seconds, and then among this packet it sends sequence number, its ID, sends signal strength, and then sleeps for a few seconds, and then it repeats. So we have two increasing values, time and counter values, and those values were not lost. Before recovering a description, I want to show few slides with pictures. Those are similars that made by Peter Merwald, but he was not using database but hashes. So because of those repeated frames, he had some slightly lower numbers of SYN packages. Those are all stations and how many signals were seen by by two stations. For example, these two stations at the same moment have seen 461,000 packets. Those two have seen 328,000 packets, and so on and so on. This graph shows only packets, situations where two stations seen more than 1,000 packets. This is activity as a number of SYN packets in entire system via time. So, as you can see, in the night it is low activity, in the day it is okay, thanks. In the night it is low activity, in the during the day many people are coming and seen in the system. Also, we can see some gaps. Maybe this was break or something, and most of the people went to some shop to buy decked phones or something like that. Those are activities as divided in groups of sequence numbers. Those are the most populated groups of counter values. So the lowest group is the most active in the beginning, and then as counter numbers increase, this group activity also decreases because most packets are going into another groups. As you can see, first it is not very active, and then activity is on the almost the last day. This is more evenly distributed. This is similar to the previous one. And here you can see that it is not even 200 packets seen in 1 minute, and here you can see that it is much more active as most tags went to the higher values of sequences. This is activity of taken from XML file. As you can see, it's almost nothing compared to activity seen from binary file. This is activity as seen in also without known points. So only in the beginning system was unable to calculate the positions, and later the graph looks almost the same. This is number of packets seen by each station. This is number of packets of particular strength. As you can see, almost all are the strongest ones. The weakest ones are about 1,000 of all SYN packets. And this graph is rather important as it gave me idea to recovering data, but this I will say in a few minutes. So the main problem was that we have not had a way to connect one packet into another packet, to be able to say that this packet comes from that person, and also that person or that person's tags generated another packet. So I had to came with idea to connect those. And I was thinking about two ways, either to first generate rather short sequences and then try to join them, or start joining from the very beginning and then so treat even one packet as a short sequence and then try to join them as if it was bigger and bigger. I have not yet implemented joining, because joining would be necessary in case of the first approach, but the first approach was not successful. So this is ideal algorithm of building sequences. We take some part of data, go through all data, take value of time and sequence, and try if those points are the next ones. This is ideal, but is not conformant to reality, because as you've seen, sometimes there are missing packets. There is not many packets with the weakest value of signal, and so on. So it is necessary to have ability to be able to cope with missing packets, with gaps in that straight line. So the first idea was to try to change slightly this algorithm to try to find the next point. If the next point is missing, switch to the next one, and then to the next one, and then so on. As values of strength were switching between 0, 85, 170, and 255. In the worst case, it should be only 2 or 3 points missing. But it was necessary to cope with conflicts, because as there is many of you that are wearing tags, it was possible that two tags had there was 2 points at the same moment with different sequence values. So it should be necessary to be able to decide which point to take. At first, I assumed that each tag was sending signals about 1.5 seconds from another, and I decided to take the point that is the closest one to this value. Also, to cope with missing values, I decided to use function that calculates distance. Because of resetting tags, when you remove battery and then put it again, tag is reset, and its counter values goes to the next 64K boundary to avoid the repetition attacks and to avoid discarding packets by server. So I decided to either return ordinary difference of sequence values, or it is if it is more than 1 minute to overflow. So to go into another boundary without reset, I decided that it was probable that tag was reset, and to return only difference in high counter values. So my program took all packets from period of time, created all alternative sequences, and then tried to choose the best ones. And this is choosing the best one. I take length of the generated subsequences, then try to calculate the slope of line, and then use the minimal square to calculate which one is the closest one to 0.5. It was possible to either treat time as base and then go by increasing counters, or by treating counter as base and increasing time. In theory, although those two approaches should give the same results, but maybe it was the part of data I decided for testing, or it was characteristic of entire data set, but treating time as base was giving less results. So it was necessary to choose the one, and in case of having more time, it could be possible to generate sequences by using two approaches and choose the best one. The first idea was an cubed algorithm, but soon I came with an squared algorithm by sorting data, and then I could go in direction of increasing time and sequence values without having to go again through entire data set. This much improved efficiency. And this is an squared algorithm. You can see it also in paper, on web page, or in proceedings. And this is approach. This is trying to join given sequences. Unfortunately, it was not very successful because most of the sequences generated were only two to three or few points. And in 1 minute, it should be about 20 points. But as most sequences were very short, joining was almost impossible because it was too much gaps between minute 1 and minute 2 or something like that. So from today's perspective, I think that I could improve this algorithm to generate much better results, but I think that global algorithm is much better. This idea came to me after looking at the graph with straight line I was showing you a few minutes ago. So the main idea is, let's calculate how slopes of all lines. Let's choose 1 point, for example, at this moment and at this sequence value, and calculate slopes of all lines that go through this point and all other points. And then let's choose slope that gets the most points in it. So it is greedy algorithm. We take histogram of all slopes. We take all points that lie on that slope or on that range, and we generate one sequence. Then we take all other points that were not yet taken into one sequence, and so on and so on. And it was generated rather big and big sequences. Only about 4,000 points were not included into one of the sequences. It was, as I was observing how this was working on database without yet plotting any graphs, I was rather pleased. However, it was giving rather strange coefficients, 0.1, 10 point something. I must add that I constrained all coefficients from 0.0 to 10.0. So it could, I imagine that it could give even stranger coefficients. This is sketch of algorithm. We take all sequence values, then for each sequence we take all times, then we calculate all that slopes, generate hash tables having histogram, then have maximum value of this, and then update all points that lie on this slope. And this is calling of this algorithm, one for each group of 64K points. The first graph looks rather nice. The second is not. It is joined many of the sequences. Basically, it is, as this is range, it took all points that lie in this range. So the second one. So it took all points that lie in this rather wide range of slopes. The third one. This part is rather nice, this one is not. Next one. The next one, this is interesting, this is example of lines that was seen in all three approaches that I was making. Next one, next one. This is a line that should be straight, but because of overflow in values. Excuse me? Which one? This is rather steep, but it only looks like, because there are small differences in points. This is residual. Those are residual points. This sequence was generated rather late, so it had not many points left, because almost all points were taken by those sequences. So only few points were left. And those are points that were left without any sequence. This is histogram of sizes of generated sequences. As you can see, it is greedy algorithm. So at the beginning of every group of 64K points, it was taking as many points as it could, and then in the end, it used whatever points were left. So I almost told you about problems. It was running for about 72 hours, but it was not in one run, but I was lefting to the night. The main problem was with coefficients of lines. I was using buckets of the size of 0.1, and it was generating those values, but this is for coefficients 0.001. It is 1,000, and as you can see, it looks very differently. And here I can see it on my screen, but you cannot on this. Here is the highest line. This is the value of slope that I should use. So at the first, I choose the too large value too large size of bucket into histogram. So I made some improvements. I refactored code, change values. Restricted histogram, use it so it uses the smallest range of slopes, and added grouping function so it does not use more than 1 point on the every second. This is code, grouping function, histogram. This grouping function was written in Python and was stored in the database. So it was called from inside a SQL statement. And though this is mostly a divided code that you already seen. And this was generating also rather interesting sequences. This is one point and all other points are here. Another sequence, another sequence, another sequence consisting of only 8 or 9 points. This is the line that you've seen in previous try. Another sequence, another sequence, another sequence. Nothing really interesting. Size of the sequences. This was one run. It was running for about 1 week. Then I get bored, interrupted this program, and ran it for another group, because during this time, 1 week of working constantly computer, it did not go outside the first group of points, the first 64K of points. So it was rather not very efficient. So it was very slow. I think it was slow because it had to calculate more buckets. I changed code so it was updated not in one run, but each point has its own transaction to update it. Also, I used grouping and used Python function to group it. So those are in my opinion, main points for this slowing. So it also had some errors, not as easily seen as in previous situations, but nonetheless there were errors. One error was that it also joined two sequences into one. Points were from the different times, but two sequences were joined. Also, it was able to join 3 or more sequences when one was ending and another was beginning. And different situation in joining sequences, when sequences with different slopes, we as humans can see that those sequences, those lines are different sequences, but for computer it was in allowed range, so it was one sequence. This is different, quite similar to previous one, but this I was allowing to happen because I assumed that if it is not many points between those situations, it can be that those lines are those points belong to one line, but do not lie on this ideal line because of rounding errors. Also, and it was done, most of the work it was done before Congress, before camp, previous camp. On the camp, Miloš published new firmware and USB made USB reader available. So I used this reader to check whether or not it is important that in database I had only 1 second values, not sub-second values of time, and only after 4th or 5th place after comma there were differences in calculating slope, so it was even below my value of bucket size of histogram. I knew that I had to come with something different to be able to have sequence generated. So I first came with idea of using strength of signal, but every tag is generating values of sequence of strength of signal in the same way, so it was not distinguishing factor. But I came with idea that I can use not not the straight range of allowed values, but to sigmoid function. So in the beginning, I allowed more wide area of slopes, and in the end, the less wide range was allowed. It helped in the problem of missing first few values. So the last thing that I haven't used was a list of scene stations, and I used this. I took list of stations seen by one point and at another point, and calculate the similarity of those lists using Python set operators. In case of conflict of 2 points that can be chosen and only one have to be chosen, I used the 1 point that had most similar station list to previous point. So the new global algorithm was to find all candidate points without using any grouping function or something like that, find all conflicting points such that time is it's not true that time is greater and sequence is greater, so it could be that times are equal or sequences are equal. Compare and choose the best subsequence, then choose choose the best candidate. I have not yet implemented case when similarity is the same, then to choose which one to choose based on which one station is the most popular, but I don't think from what I've seen in data that it is a problem. And put this line into database. So I choose all points, use all points, not only one on the line, to generate alternative subsequences. It was returning to local algorithm with generating subsequences and choosing the best one. And I use PostgreSQL arrays and accumulator function to get all stations and all strength of signals. This is function calculating similarity. One case when strengths are different, and then I had to calculate it in slightly different ways, that size of set being intersection and sum of the sets. Generating all points that can create line, taking all possible sequences. If there is for each candidate sequence, let's calculate if point is according to all previous points. If it is, add. If it's not, create another alternative subsequence. Then choosing the best line, I've used five different approaches. Using the longest one, the best alternative for station in the beginning, for the station in the end, for slopes similarity in the beginning and slope similarity in the end. And the one subsequence that was that had the best characteristics in all five groups was chosen. And another difference, I've added function that was able to break line if it was problem that the line was joined of two other lines. And this is function that calls all previous functions, gets histogram, fetches all the points, create all lines, create one line, then updates, and if it is probable that it is joined, break the line. And these are graphs of that came from this algorithm. Some have only few points. This is similar to one pointed by Miloš, consisting of only few points. This is rather interesting. This is one that was also seen by Peter Merwald, the one from a person that had a tag that had very high values of counter. It was only one person that had 4 billion something in the values of counter. This is histogram of all sequences. I don't know why after initial rather ordinary looking sequences we've seen increase of size. I don't know it yet. I have changed computer. So it was running on 64-bit AMD with rather larger amount of RAM. It used 10.6 million points, and it was stopped because of error in function calculating slope, the slope white. And now it is time, I think, to try to join sequences. So, the one problem I discovered by analyzing firmware, it was that firmware is using a random number to sleep. First it sleeps about 2 seconds and then it sleeps random time. So if it sleeps for random time, it should be no straight line in data, because this tag could sleep now 1 second, then 3 seconds, then 2 seconds, and so on. But it has straight lines. I thought that it was possible because I have so many points that if I was drawing something, I would come with straight lines. But by using a reader, I discovered that that tag is generating rather straight lines. So I don't know why it was not using proper random generator. Maybe on this architecture, random generator is broken or something. I have not yet used ordinary distance between stations. So, for example, by restricting that people walk, don't teleport between stations. But I don't think if it is necessary. And now I have few remarks on what now can be done, but I have not yet implemented this as I wanted to be able to generate sequences, to try if it's possible to recover sequences. First is position estimation. It is mostly done, but maybe I could try with another algorithm or my own implementation. It could be possible to calculate direction of person, because when tag can see reader, it has one strength, and when tag is behind me, about 50% of signal strength is lost. So it could be done to, it could be possible to calculate direction of person, assuming, of course, that all people wear tags in the front, not in the back. Another ideas, it could be to calculate how many people leave BCC and when people are leaving. Maybe it could be possible that most people leave BCC, but some stay overnight or something like that. And the most interesting would be to try to have connections between people, either by finding all people that have similar interests. For example, if I attend some group of talks and another person attends the similar group of talks, it means that we have similar areas of interest. Also, to find friends. Friends, in my opinion, are people that are close together not only during talks but also during breaks and stay with closely to one another in the queue for coffee or pizza or something like that. And also I used XML data to try to draw positions of all tags in a plan of Sputnik. This is small Python script that takes all points. Those are x min, x max, y min, y max, z min, z max, and it can also draw all points from one time period to another time period, and then to make some animation to step in few time steps. Okay. How much time do we have? 10 minutes. Okay. I hope that there are some questions. Yeah.
Okay. I have a comment on the sequence number, because actually that's two word values.
Excuse me?
The sequence number is actually two word values as implemented in the Sputnik tag. And I think there is another bug in the original firmware that fails to update the high word when the low word wraps around. That's due to an optimization, because if you would update the sequence counter, which is stored in Flash, it would wear out too fast, because if you constantly write that, you will break the Flash. And I think that due to this bug, the low word will just wrap around without incrementing the high word. So you will have it will go back to zero basically, and the high word in the sequence number is just incremented when you turn on off. So I think this could severely influence your analysis.
I have not known this.
It is reported on the mailing list for the Sputnik analysis.
Yeah, but the wrapping occurs something like 2.5 days or so, so it still works.
I don't think that it will be relevant in my case, because I only used groups of 64K values. So I want, in my case, I was not analyzing in global algorithm. I was not analyzing a case when there is wrap. So that's maybe that was gut feeling or something, but I did not analyze this case.
Yeah, I think it doesn't influence your analysis, because in fact you haven't looked at the upper 32 bits, because you assume that it could change because of power cycling. So you only looked at the lower 16 bits. So I think it wouldn't also influence your analysis. So your analysis is right, in my opinion.
And I think in analysis, when we assume that we have already valid sequences, it also won't be relevant, because we will, for example, from what I have, from ideas that I have, it will be that I will also only look at time, position, and tag ID, not value of sequence, because this is only used to avoid replay attacks and something like that. So for real analysis, it won't be necessary to have valid sequence values.
Any other questions?
In the back.
What data type did you use for the coefficients of those lines? Are those simple floats?
It was float, or not, it was rather double. In Postgres, I was casting in Postgres. I was storing time as timestamp with time zone, and sequence values as long value, 64-bit value, because of that one person that had a strange tag that was having these large numbers, and I was casting those values to double, and then taking it into Python.
Because in linear algebra there is a very large error. The error is multiplied when you have small coefficients, and the binary representation of floats is not really suitable for.
Yes, in small values, yes. That's why I have used sigmoid function to have wider range of coefficients in the beginning of the set I was looking at.
Thank you.
Okay.
So, any more questions?
If not, I may add a few words from what I see in maybe from scientific or Milos wants to.
Just a general question. If Peter Merwald is here, I want to meet him, so we can meet later. It would be cool.
Okay, from what I think now is from to analyze data. Analyzing data will require joining local algorithms to find the minimal strength of signal to be able to calculate the exact position of person, and global algorithms to be able to trace people in longer periods of time. So that's why I wanted to show you the both approaches that I was taking. If there is no questions, thank you for your attention.